So chapter 3, section 2 is called Using Parallel Lines and Transversals. So it's taking everything that we learned about what those special angles are, the alternate interior, the alternate exteriors, the same side interior, consecutive interior, and corresponding, and applying it to angles that have a special relationship because those lines that are the two lines that the transversals intersecting are parallel. So we're taking it kind of a step further. So they all these theorems start the exact same way. If two lines are cut by two parallel lines, are cut by a transversal, so this is the most important word in the beginning. If two parallel lines are cut by a transversal, then corresponding angles are congruent, and that's the corresponding angles postulate. Two parallel lines cut by a transversal, then alternate interior angles are congruent, and that's alternate interior angles theorem. If two parallel lines are cut by a transversal, alternate exterior angles are congruent. That's alternate exterior angles theorem. And if two parallel lines are cut by a transversal, same side interior or consecutive interior are supplementary. So corresponding alternate interior, alternate exterior, all congruent, same side interior are supplementary. So you can either, like if you're using this in a proof for a reason, you can write out that whole thing. If two parallel lines are cut by a transversal, then blank is congruent. Or you can learn the names. But you have to make sure you know the full name. Corresponding angles is the postulate, alternate interior, alternate exterior, and consecutive are all theorems. All right, so again, one postulate, three theorems, okay? Corresponding, alternate interior, alternate exterior, all congruent, and then same side interior or consecutive interior are supplementary, which means what? Good, 180 degrees. All right, so this is find the measures, okay? So there's a lot going on in this graph. This chart, you got to kind of look at it separately. One is that these little arrows mean that these lines are parallel, okay? So it's establishing these lines are parallel. Now you actually have two transversals. You have this one here, which means I can look at all 8 of these angles and figure out their relationships. You also have this transversal, which means there are another set of 8 angles right here that I can look at those relationships. So now figure out, first of all, what are the relationships between the angles, and then what type of angle they are. What does that mean? So before I even look at the left-hand side, let's look at the diagram. What's true? Let's look at the left. What's true about angle 8 and this angle up here? What is the relationship? They are congruent, but why? They're corresponding. Yes? And corresponding angles, yes? Are congruent. So this is also 90 degrees, okay? That's the first thing I know. Now go to all the 8 on the right-hand side, okay? There's a lot of different relationships going on. You've got linear pairs, you've got vertical angles, you've got corresponding, you've got consecutive interior, you've got alternate interior, you've got alternate exterior. So there's a lot of different ways to figure it out. You only need one measure, which is at 130. So tell me first, what other angles are 130 degrees? Sophia. 6 is 130 degrees, and why is that? Those are vertical angles. Good. What else, Connor? 2 is because 2 reasons. 1, alternate exterior to 6, right? Or corresponding to the 130. Everybody see that? Yeah. Yes? And then we said 3 is 130, and why is that? Vertical angles with 2, corresponding with 6, or alternate interior with my original 130. Did everybody see that? Yeah. Yep. Okay, so now that means every other angle is what?
It's
50. And why is that?
Because 50 plus 130 is 180.
Good. These are 180. These are 180. If that's 50, this is 50 because of vertical angles or the other linear pair, right? If 7 is 50, then 1 is 50 because of alternate exterior or the linear pairs that are formed up there. And 4 can be 50 because it's corresponding to 7, or it's a linear pair with 2, linear pair with 3, alternate interior with 5, right? Like all those relationships overlap. So now we have all the measures we need, right? Angle 1 is 50 degrees. Angle 2 is 130 degrees. Angle 3 is 130 degrees. Angle 4, 50 degrees. Angle 5, 50 degrees. Angle 6, 130. Angle 7, 50. And angle 8, 90 degrees.
Oh, and then this test we're gonna have to completely.
Yup, quiz 2. I warned you it was coming. All right, so let's look at what I actually have a value for, which is the 110, right? It's the only one I actually know a value for. If this is 110 and I want to find x, what's the relationship between those two angles? Okay, you're right. Supplementary, but what are they called?
Oh, they're called interior angles are supplementary.
Consecutive, if you just like put it all together, right? Those consecutive interior, right? And the consecutive interior one is it a theorem or a postulate?
Theorem.
Okay, and it says that they're supplementary, which means that x plus 110 equals 180, and x would equal 70. Good. Okay, that's this one.
If you did it like a different way, do you have to like still know how to do it the other way?
What do you mean?
One.
No. Okay, so that was a great question. Guys, shh. So the question is, what if I use the corresponding angles here first? Totally fine. 110 would equal 2z, making z 55, right? So now I have that one. And then I can go there to here. Those two are same side interior. Or I can go here to here, and those are corresponding, which means y is what? 35. So it doesn't matter which pair of angles you're using. All those rules still apply.
110 was equal.
This says, when sunlight enters a drop of rain, different colors of light leave the drop at different angles. This process is what makes a rainbow. For violet light, the measure of angle 2 is 40 degrees. So this one here is 40 degrees. What is the measure of angle 1, and how do you know?
Is it 40 degrees?
Why is it 40 degrees? Alternate interior angles. Theorem. So which one's the postulate? Which is what? Corresponding. Corresponding is the postulate. All the other ones are theorems, right? And which one is supplementary?
That's the last one.
Consecutive interior, same side interior, right? And then all the rest of them are congruent. Yes?
Can you say about the supplementary? What was it?
Which the one? So alternate interior, alt exterior, corresponding are all congruent, and then consecutive interior is supplementary. And then this, and this are all the theorems. And this one is the postulate.
Why is that one a postulate? The other
I
one?
don't know. Just the way in which they were proven. It took, like that one, it's usually more based on a definition than going, if this is true, then this is true, kind of a scenario.
For the consecutive interior one, for like the supplements, can it also be like one of the consecutive interiors and one of the consecutive exteriors?
There's no such thing as consecutive exterior.
I know.
Oh, but like if you're saying like if you're using these, if you're saying like those two, you mean? That would be linear pair.
Oh, yeah.
Yep. So if you're showing that those are supplementary, that's linear pair postulate.
Why are they the same?
Because they're alternate interior angles.